Hi, everybody. It's Professor Mitchell. Today we're talking about section 1.8, inverse functions. We are building up to inverse trigonometric functions. So in the last video, we talked about composite functions. Composite functions are an important concept to understand inverse functions. In this section, we are going to verify inverse functions, find the inverse of a function, use the horizontal line test to determine if a function has an inverse. Not all functions even have inverse functions. And then use the graph of a one-to-one function. A one-to-one function is the kind of function that has an inverse. To graph the inverse function. Okay. And then this last point just kind of ties all that other stuff together. Okay. So if this looks familiar, it's because I used the same analogy in the last section. You may recall from the last section that I talked about my flight home for Christmas, home to Jersey. So that analogy still works for this. So let's say that one year for Christmas I get lucky and I get a direct flight. So I get a direct flight from Sacramento all the way to lovely exotic Newark. Okay, on flight F. And let's say that flight F takes me from gate 5 in Sacramento to gate 20 in Newark. Well, it's great to see the family back in Jersey, but at some point I have to come back and, go back to work and stuff. And so sometime around January 4th, I'm going to get on a plane in Newark and fly back to Sacramento. Okay. This is the idea behind an inverse function. So in this story, f of 5 is 20. Function f takes me from the number 5 to the number 20. And this new function I'm talking about, which is called f inverse, and in a minute you'll hear me complaining about the notation for this. I absolutely hate this notation, but it's what we're stuck with. Takes me from the number 20 back to the number 5. Okay. So the idea behind an inverse function is that it just undoes whatever the original function did. If the original function takes the numbers 1, 2, and 3 to the numbers 10, 20, and 30, then the inverse function is going to take the numbers 10, 20, 30 back to the numbers 1, 2, and 3. It just undoes whatever the original function did. And you can come up with all sorts of real life examples for this. If function f is taking off your shoes, then f inverse is putting on your shoes. All right. Function f is packing the groceries. Function f inverse is unpacking them. So it's just undoing whatever the original function did. Okay. So the idea here, I'm going to sort of warm you up for the official definition, is that the original function took me from 5 to 20, and the inverse function took me from 20 back to 5. And so if I took the composition of these two functions, I guess, well, really either way, but I'll start with f inverse circle f. So remember, f inverse circle f means function f goes first. F would take me from 5 to 20. F inverse would take me from 20 back to 5. So f inverse circle f of 5 would just be 5. It would take you back to the original number. And if I do it the other way, let's see, which way did I just do it? I did f inverse circle f. So now I'm going to do f circle f inverse. That means I have to start over here. F inverse takes me from 20 to 5. F takes me from 5 back to 20. So f circle f inverse of 20 would be 20. It would just take you back to the original number. And that is going to be the definition of what inverse functions do. And that's what you see right here. So if f and g are two functions such that not only is f of g of x equal to x for every x in the domain of G. So there may just be certain values of x that make this work. So it has to work for at least those values. And not only that, but G of f of x also has to equal x for every x in the domain of f. So f and G may not have the same domain, okay? But for every number that's in the domain of G, f of G of x has to be x, and for every number that's in the domain of f, G of f of x has to be x. Okay? So when you apply one function followed by the other function, if it always takes you back to where you started, then those two functions are inverses of each other. So let's look at an example. Oh, sorry, a little more notation. And again, you just heard me complaining about this notation. So I want to caution you about what this does not mean. All right. You probably learned in some class that -1 power means reciprocal. I don't think we've talked about that in here yet. I can't remember. That is not what this means. All right. So this sort of notation with the superscript -1 can mean two different things in math. It can mean -1 exponent, which means reciprocal, but it can also mean inverse. So you never, ever want to read this as f to the -1. That is not what that means. This is read f inverse. So this is just a certain kind of function. Okay. All right. So here's our example. They want us to show that each function is the inverse of the other. So you do that using the definition. So the first thing I'm going to do, okay, and again, I apologize that this all comes up at once. I'm going to talk you through it. First thing you do is show that f of g of x is just x. And that's, again, my function composition. So f of g of x. First step, replace g of x with what g of x is. Okay, g of x is x plus 7 all over 4. Then you want to think about what function f does. So function f is a pretty simple function. It just takes a number, multiplies it by 4, and then subtracts 7. So that is exactly what I'm going to do to this thing. I'm going to multiply it by 4, and then I'm going to subtract 7. So when you get to a certain point, you can kind of see where this is going. 4 times x plus 7 over 4, well, the 4's are going to cancel, right? So that's going to leave me with x plus 7 minus 7. Maybe it would be good to put this x plus 7 in parentheses. Okay. But of course, I don't really need the parentheses. X plus 7 minus 7 is just x. So I like that. They asked me to verify that these are inverses. If that didn't come out to be x, that would mean something's wrong. All right. Either I did something wrong or they're lying to me, and these are not really inverses of each other. But I don't think they're going to do that to you, at least not on purpose. All right. So you do have to check it going the other way. I don't mind telling you that 99% of the time, if it works for f of g of x, it's also going to work for g of f of x. So the same kind of deal. G of f of x is 4x minus 7. Okay. Now I have to think about what function g does. Maybe I'll use a triangle this time. Okay, function g takes a number, adds 7, and then divides the answer by 4. So that is exactly what I'm going to do to 4x minus 7. All right, put a, that doesn't really look like a triangle. Okay, put a 4x minus 7 inside the triangle. So I'm going to add 7 to that and then divide by 4. So of course the minus 7 plus 7 cancels. That leaves me with 4x over 4, which is x. Woohoo! Okay, and again, I was really hoping it would come out to be x because they told me these functions were inverses. So if anything else had happened, that means something's wrong. All right, so the next thing we're going to talk about is when they only give you one of the functions, how do you find the inverse of that function? Assuming the function has an inverse, all right, that's something we still have to talk about. Not all functions have inverses. We'll talk about that later. Okay, so these are the steps for finding the inverse of a function. The first thing you do is if they've given you the function using function notation, you replace the f of x with a y. Okay, and of course, I'm going to show you, I think I have two examples of this. Replace f of x with y. And the reason we do that is because in the next step, we're going to interchange all the x's and y's. This is really where the function turns into the inverse of the function, because remember, the original function takes x to y. The inverse function is going to do the reverse. It's going to take y back to x. Okay. So at this point, you've really created your inverse function. So all you have to do now is just write it using correct function notation, which means solve for y. All right. Functions are always written solve for y. Okay. Now, if you can't solve for y, and this really takes me back to a long time ago, way back at the beginning of chapter 1, we would have talked about this, I want to say in section 1.2 or something. We talked about when they hand you an equation, figuring out from the equation whether it defines y as a function of x. So for example, if you have to use plus or minus to solve it for y, then that's not really a function. So if that happens at this step, then it really means you can stop and just say that the original function they gave you doesn't have an inverse. Okay. But most of the time it will have an inverse. And then the last step is just write it using the correct notation, f inverse of x instead of y. And then if you want to check your answer, you can use the definition, just show that f of f inverse of x is x, and also show that f inverse of f of x is x. All right, so the first example of finding the inverse of a function is this one. Find the inverse of f of x equals 2x plus 7. And I believe I did some work to make this so that it really would come up one step at a time. I'm pretty sure oh, you know what, maybe that was the next one. Oh no, okay, it is coming up one step at a time. So the first step is replace f of x with y. So that's really simple. Instead of writing f of x equals 2x plus 7, they want you to write y equals 2x plus 7. And the reason for that is because in step 2, they're going to have you interchange x and y. So this is where you're really creating the inverse of the function. Okay. All right, the next step, step 3, is where you're going to spend about 90% of your time. All right, that's definitely the step that takes the most work. So let's see what that looks like. Okay. All right, so we're going to solve this thing for y. So we start with x equals 2y plus 7. The first thing I'm going to do to solve that for y is subtract 7 on both sides. See that? So the plus 7 minus 7 on this side cancel and just leave me with x minus 7 equals 2y. And then I'm going to divide both sides by 2 to get that 2 away from the y. Okay, so goodbye, goodbye. And that leaves me with y equals x minus 7 over 2. Okay. So I think that's my inverse function. When I'm ready to write my answer, I will write it using function notation. I'll say f inverse of x equals x minus 7 over 2. One thing I like is that the simpler examples are pretty easy to understand, just almost from a common sense perspective. If you understand that an inverse is supposed to undo the original function, just think about what function f does. It takes a number, multiplies it by 2, and adds 7. Okay, it multiplies by 2, and then it adds 7. Okay, so how would I undo multiplying by 2 and then adding 7, well, I would start by subtracting 7. So in other words, we did these things in this order. I have to undo them in the opposite order. So I'm going to subtract 7 and then divide by 2. So if you think about what does subtract 7 and then divide by 2 look like, it looks exactly like this.